purpose of this video is for you to use some tips for how to predict problems to write equations for those reactions, single and double displacement and synthesis. Now the first thing to consider, or the first tip, is that there are 7 diatomic elements. Here they are. What a diatomic element is something, when it's in an equation, there's 2 of them, or that its subscript will be 2. So the correct way to write this, chlorine, would be with a 2 of a subscript, unlike this, where there's no subscript. The second thing is that metals, when they appear in the chemical equation, and by metals I mean anything here in the red, when they're alone in a chemical equation, their subscript will be nothing, in that it'll be 1. It'll be one of them. They're not going to write the 1. It's just going to be like Na or Fe or Mg. They're not going to have 3 of a subscript of a 2. You have to change the coefficients. And the same thing, Na doesn't have a subscript. That'd be correct. Here it would be incorrect. Third tip is that the subscripts on the left side don't have to be the same on the right. This is a really common mistake. This would be correct. When these 2 elements are alone, they are diatomic, so it's H2 and O2, but when they're together, there's 2 hydrogens for every 1 oxygen. Here's another correct example. An incorrect example would be that you assumed, since there's a 2 here, there have to be a 2 here. And the same thing here. That would be incorrect. Now, the next tip is you got to know your charges. Now, for the main group elements, you go by the group. And by main group, that's this group, and these 5 groups here. And it goes +1, +2, +3, plus or minus 4, plus -3, -2, -1. These don't have a charge. Now, for transition metals, and these are transition metals, for these you're going to go by the Roman numeral given. For example, if it's Fe3, that means the charge on the iron is +3. Or you're going to go by what it's bonded to. Say we've got zinc hydroxide. Now, I've got 1 zinc. I want to know its charge. I know it's with 2 hydroxides, an O and an H. And each hydroxide has a -1 charge. Therefore, the zinc has to neutralize it out. Therefore, it would have to be +2. Here's another example. You've got a cobalt atom with 2 carbonates, and each carbonate's charge is a -2. Therefore, the overall charge on this has to be +4. Now, in these kind of reactions, your charges are not going to change. What this means is, here, this iron, its charge is the chlorines each are -1, so the iron has to be +3, because it's with 3 chlorines. Therefore, when I wrote the product, it would have to continue to be that charge. Charges don't depend upon the subscript. That's the next tip. For example, in this, sodium and chlorine. Chloride. Sodium reacting with chlorine. You'd look them up on the periodic table. Here's sodium. It's in group 1. It's +1. Chlorine is in group 17. It's a -1. Therefore, now you can predict the product. However, when you go to write it, you don't let this number right here, this 2, influence what the charge is. charge is going to remain -1. You're not going to assume that it's -2 and therefore write the formula like this. You're going to assume, or not assume, but say that it's going to be the same as it is in the group, and it's going to remain -1 regardless of what the subscript is, and get this product. Now, this next tip is that in displacement reaction, like things swap. So C is a cation, A is an anion. This is like two compounds. I've got a compound, a cation and an anion, a cation and anion. They're not the same. This cation is going to swap spots with this cation, or this one's going to swap with that, one or the other. And I'm going to end with this. Now, in a single displacement, it looks kind of like this. The only thing is that you have to go, if it's a cation, it's going to swap with that, and it's going to swap with that. It's negative charge. Now, the last tip is to identify the reaction type and follow its pattern. For example, what is this? This has got to be a synthesis reaction because they have two things that are coming together, and they're two elements. Therefore, I'd look up their charges, +1, -1, and I'd write the product. This one is going to be a double displacement. I've got two compounds. Therefore, the anion and the cation, the cation of one is going to swap with the cation of the other. Gosh. The cation of one is going to swap with the cation of the other, and I'm going to make a neutral compound. And that's what it would be. And the final one, this is a compound and an element. That would be single displacement. So copper is a cation, so it's going to take the place of iron. And this would be what I would get.